Hi, guys. Happy Cinco de Mayo, which stands for May 5th. So, taking a look over here on the right hand side, you guys are going to be working through this presentation with me, and you're going to need your math workbooks. At the end of the lesson, you will complete a Google form, and you still have your iReady path, 15 minutes each day. You need to hit 60 minutes by the end of the week. So I don't know if you guys heard, but on Monday, the governor of New Jersey did announce that New Jersey schools will stay closed through the end of this academic school year, which means that we will be continuing to learn. It's just going to end the year doing this distance learning situation. So I was really sad to hear that I wouldn't get to see you guys in person, but as we get more information, I will make sure to keep you posted. But today is a day where I am starting my Google Meets. So if you're watching this video before 8:30, I will see this group from 8:30 to 9. And then in the late afternoon during my third switch time, I'm going to be working with this group here under Tuesday. All of you received an email for the Google Meet. So if you are in this group here or this group here and you did not receive an email, please reach out. And then this will be the group, these two groups right here, that I will be working with tomorrow. So you guys will be getting your links in your emails later on tonight. All right. So we are going to continue with our geometry standard where we are looking at those attributes and we are grouping shapes based off of those attributes into categories and subcategories, as well as we're working on classifying two-dimensional figures in a hierarchy. So those are our two main objectives. Today we're starting lesson 29 in your workbooks, and this is an explore lesson. So remember, explore lessons, you are meant to struggle a little bit. The information is still new. So again, make sure you're pushing pause in the video and giving it your best shot in your workbooks and fixing your work as needed throughout this presentation. So if you haven't gotten your workbook already, please push pause on the video and go find it. If you need to get a notebook or sharpen your pencil, please do that now as well. Once you do have your workbook, we're going to open up to page 587. And right before 587, you can see that it has the family letters. If you want to show that to your families, it gives an overview and some activities that you could be doing at home with your families to practice more math skills that have to do with this topic. All right, so before we get started on page 587, I just want to review with you these key vocabulary terms. An attribute, remember, is a trait, and it's when we are looking at these characteristics such as the number of sides, how long the sides are, how many angles there are, what types of angles. So you're really looking at all of those key features of the shapes. A category is when we group shapes or things together based on a common attribute. And then you can get more specific is you break it down into subcategories. And then you can remember that we used a Venn diagram with those overlapping ovals, or sometimes the ovals are completely inside other ovals, as well as a tree diagram. So taking a look, you can see this is our try it section. So here you're being asked to make sense of this problem and go ahead and see what you can create in your workbooks. So as I'm reading this over, you want to remember to think about what is important in the problem. What are we trying to figure out? And what information is important? So you can see those three questions down there that you want to ask yourself as you are completing this task. It says, arrange the quadrilaterals shown below into a Venn diagram that shows a hierarchy of categories from most general to most specific. Label the categories represented by these shapes in your Venn diagram. So, who or what is this problem about? Well, this problem is about shapes, and you are being asked to draw a Venn diagram to represent their relationships based off of shared attributes, And when you do this, you really want to take a look at what are these shapes called? Why are they classified the way that they are? So here I can see this shape has some right angles. I see the top line and the bottom line are parallel, and the left and the right are parallel. I see that the top and the bottom are the same size. I can see it's 1, 2, 3, 4 blocks long, and it's 1, 2 blocks high, so I can see all that. This shape here, again, I don't see any right angles, but I do see 2 sets of parallel sides. And it also looks like the left side and the right side are the same length, as well as the top and the bottom. And finally, this last shape over here, I can see, again, those right angles similar to that first shape. As well as when I look at how long the sides are, I can see that each side has a length of 1, 2, 3 blocks. So the left is 3 blocks, the bottom is 3 blocks, the right is 3 blocks, and the top is 3 blocks. So if you need to flip back to previous pages to take a look at a Venn diagram example, go ahead and do that. But you're going to push pause on this video. You're going to try and create your own Venn diagram with these shapes here. And don't forget, you're being asked to label the categories. When you're done, come back and push play. All right, so let's take a look here. So you can see that I have those 3 shapes again, and this outer oval is going to be the most general, okay? Or you can also say least specific. That's saying the same thing. Most general and least specific are the same thing. So you can see that in this last oval, I'm going to call this a parallelogram. Now, when you're taking a look at your model, please make sure to fix any inconsistencies. Did you have all of your ovals inside each other? If not, like I said, go ahead and draw the correct version now. So now you can see that this middle oval is right here, which means that everything inside this middle oval is a subcategory or more specific type of parallelogram. So I know that I have this shape or this shape. So which one do you think is going to come next? A rectangle. Why? Because a rectangle has all of the attributes of a parallelogram, but it also has right angles. That's what makes it a little bit more specific. That means that this shape here has to be the most specific because a square has all of the attributes to be called a rectangle, as well as all of the attributes to be called a parallelogram. So that's why it's inside the rectangle, which is inside the parallelogram. All right. So here you're being asked to explain how you organize the shapes in your Venn diagram. So again, if you made a mistake, you should have corrected it and have the correct Venn diagram. So I want you to take a look at why did we build it the way that we did. Go ahead, push pause on the video, use these characteristics down here to help you, and then we'll go over it when you come back. All right, so taking a look here, this is just one possible answer. The parallelogram is the outer region because the rectangle and square have all the attributes, great vocabulary word there, of a parallelogram. So rectangles and squares are subcategories of parallelograms. The rectangle is next and the square is last because a square has all the attributes of a rectangle. So again, you can see here how the parallelogram has these 2 bullet points. A square and a rectangle also have those qualifications, but then again, a square is also more specific because all those sides are equal. So if you didn't have words like attributes and subcategories in your definition, or excuse me, your answer to this question, please update that now. All right. So here's number 2, and you're going to be asked to complete this all on your own. It says in the Venn diagram below, the red and blue ovals represent subcategories of polygons. 3 polygons are placed into the ovals with 1 shape in both ovals. So let's take a look. So this outer oval of the Venn diagram represents all polygons, okay? So I can put anything that is a closed figure made up of straight lines. I could put a hexagon in here, a nonagon. I can put triangles. I can put pentagons. I could put trapezoids. But then here you have this red circle, and you can see that I have here, this looks like it is an isosceles right triangle. Over here, this looks like I have a square, and right here, it looks like I have an equilateral acute triangle. So in parts A, B, C, and D, the first thing you're trying to figure out is what property is shared by the two shapes in the red oval. So what's the same with this and this? What is a characteristic, an attribute, a property, another word for attribute that they share? Part B, what is shared by the two shapes in the blue oval? So now I'm going to look at, all right, well, what could this shape and what could this shape have in common? And you're going to jot down your ideas. Then you're going to use your answers to parts A and B to come up with the name of this subcategory and this subcategory. And then we're going to talk about why is the equilateral triangle, which is this one right here, in both the red and blue ovals. So go ahead and explore this. Push pause on the video now and come back and push play when you're ready. All right, so this was a big problem for us to take a look at, a lot of steps. So the first thing you had to look at is what property is shared by the two shapes in the red oval. Well, I can see that they both have three sides. They both have three angles. I can see they both have at least two acute angles. They're both triangles. Let's see. So again, you could have had many different answers. One possible one that I'm going with is they both have three sides. Again, you could have put they both had three angles. So now let's take a look at the blue oval. Well, what property do these two things share? It's definitely not the number of sides. It's definitely not the number of angles or even the kind of angles, because these look like they're all acute and these are all right. So you should have said that they have all equal side lengths. This is an equilateral triangle and this is a square. So the top, the bottom, the left, and the right are all the same side length. The left, the right, and the base are all the same. So these two shapes can be grouped together because they have the same side lengths. So now we had to use our answers in part A and B to come up with names for these subcategories. Well, the red oval, I think, is a little easier for us. You should have said triangles. Now, this blue oval was actually a term that we went over a couple videos ago, and you might have forgotten it or struggled here. But any shape that has all equal sides and all equal angles is called equilateral polygons. Again, you can see that word equal in there. So a special term, a subcategory, equilateral polygons for these two. So why is the equilateral triangle in both? Well, because it shares the attributes of triangles as well as equilateral polygons. So an equilateral triangle has three sides and all equal sides. So it meets the rules for this subcategory and this subcategory, and that's why it overlaps. All right, so here I'm asking you to reflect in a Venn diagram what is true about two categories represented by ovals that overlap. Okay, without one oval being completely inside the other. So that's that example that we just looked at. Push pause, jot down your ideas, and come back and push play when you're ready. All right, so again, I just kind of talked about this back when we were looking at problem 2, but you could have said something like shapes in the two categories have some traits that are the same, but not all of the properties of the other category. So again, going back here, well, this has some of this, but not all of it, and vice versa. So be careful there. All right. So you're going to want to flip to page 590. You can see right up in the corner, and you can see that this problem's looking with some Tostito chips and salsa. Perfect for Cinco de Mayo. So it says, arrange the triangles below into the Venn diagram. Label each oval as a category of triangles. So again, remember you can classify your triangles based on their sides and based on their angles. So take a look at these 3 triangles and go ahead and try to create your own Venn diagram. Push pause and come back when you are ready to go over it. All right, so let's take a look at what you could have created. Now, before I reveal an example of what we're looking for, I want to remind you that today is the Explore Day. So if you're making some mistakes, that's okay. Have a growth mindset because we're going to be continuing to work with these standards to build our knowledge. Today is just day 1 of lesson 29. So taking a look here, you can see that on this side, this oval represents right triangles. Why? Because you can see that these two, if I were to classify them by their angles, you can see that square corner right there. Now, this one here, believe it or not, and this one here, they're both isosceles. All the sides, the left and the right here are the same, and these two sides here are the same. So, an isosceles is not all the sides that are the same, it's when 2 sides are the same. So this triangle is a right triangle, but it's also an isosceles triangle. So that's why it's right in the middle and shares both those ovals. So again, I just want to remind you of this nice chart. It is included in the slide presentation. You are going to now head over and do your Google Form exit ticket. I want to remind you that I included this chart as well as the rules for classifying triangles. And I want you to use those charts to really help you answer today's questions for the end of the lesson. If I get to see you today in our Google Meets, I'm really looking forward to it. Those of you who aren't going today, I'm excited to see you later on in the week. So please remember to reach out through email if you have any questions about today's lesson. All right, guys, happy Cinco de Mayo.